Welcome back to Basic Mathematics. In this video, we're going to be looking at the art of problem solving. Problem solving is a catch-all term for the process of using mathematics to model a situation that occurs in the world and find a solution. Very often you hear that mathematics is the language of problem solving. The step-by-step process of evaluating an expression using the order of operations is exactly the tool that you need in order to think through the step-by-step logic of solving a problem in the world. In this course, we are going to stick with problems that involve numerical solutions and are going to be solved using properties of arithmetic, setting up expressions, and the other things that we're going to be looking at. But the process that I'm going to be teaching here is usable for solving a number of problems where it's not obvious at first if there is a numerical backbone to it, or if mathematics feels like the right thing at all. For those of you moving onward from this course, you most likely at some point will be taking a course which has a strong problem-solving foundation. And I hope that you get the chance to see how some of these techniques can be applied to problems that are not numerical in nature. So let me get my head out of the way and let's dive right in. There are a number of different 3-step, 4-step, 5-step, I've even seen 7-step problem-solving strategies that show up in various textbooks. I want to take you back to the beginning of all of it. A Hungarian mathematician named George Polya came up with the 4-step approach of problem solving in a textbook that he wrote called How to Solve It, which was published in 1945. Prior to Polya's textbook, problem solving was not addressed as a standalone subject in any math textbook ever. You had problems to solve, but it was just assumed that if you had seen how to do the mathematics, you could figure out on your own how to use that math to solve problems. Since How to Solve It was published, there's not been a math book come out at anything below the upper undergraduate level, 300 and 400 level math classes, that does not include some commentary on the 4-step problem-solving strategy or something related to it. The interesting thing I find about the 4-step problem-solving strategy, George Polya wrote it in 1945 or somewhere thereabouts, early 1940s and late 1930s. In 2016, a team of researchers at Carnegie Mellon University in Pittsburgh got freshman math majors to volunteer to solve problems while in an MRI. And what they saw was that the students, the volunteers, test subjects, used 4 distinct different parts of their brain as they went through the process of solving the problem. So when we look at the 4-step approach here, when we look at these 4 steps, even though the 4-step method of problem solving predates really anything involving neuroscience, it turns out that it's based in neuroscience. Step 1 is to understand the problem. Step 1, I think, is the obvious part of the process, it's one that students tend to not want to spend as much time on as they should. If you don't know what you're doing, how can you start doing it? Point blank, that's what step one is all about. So, my suggestion, first, read the problem carefully. In any classroom situation, you're going to be dealing with problems that are written out in paragraph form for you to read and interpret. Read the problem from beginning to end, carefully, slowly if you need to. Make sure that you get a basic idea of what's going on. Once you have done that, go back to the beginning and do the whole thing over again. Read the problem from beginning to end. The second time, take notes. Jot down phrases, numbers, pictures, whatever else might be useful, so that you can easily answer the question, what do you know and what do you need to know in order to solve this problem? Step two is absolutely the critical step of the process. Step two is to plan your approach. Decide how you are going to approach the problem. Decide what steps you are going to take. Are you going to write out an equation or an expression? Does the problem involve addition, subtraction, multiplication, division, something else? How do you solve this problem? What should you do? Oftentimes, we don't write anything down in the step where we plan the solution. And because of that, step two often feels like it's missed. And for students, it tends to be hard to learn step two because there's nothing written down. But step two is definitely the vital step. Step three is called execute. I like to call this the do math step. Whatever plan you have, this is the step where you do it. If you said your plan was to write out an expression, write it. If you said your plan was to add some stuff. If you said your plan was to draw a picture, draw the picture. And then finally, step four is interpret. There are a couple of things going on in step four, but I had a student a couple of semesters ago tell me it was the sound smart step, and I really like that description. Step four of the process is to look at the result you came up with. In this course, it's always going to be a numerical result, and use that numerical result to make sure you're answering the question. One of my favorite examples, something we'll get into not this week, but a little bit later on in the course. If you are asked to determine how many buses does it take to get all the students on this field trip to their destination, and you answer it's going to take 2.73 buses. What is 0.73 of a bus? Likewise, if you're asked to determine how many people you can put on the ship before it has too much capacity and can't float anymore, and you tell me that the ship can hold 12.15 people, what is 0.15 of a person? So step 4 is going to be looking at numbers like that and trying to figure out what they actually mean in terms of solving the problem. Step 4 is also going to involve making sure that you answer the right question. I tend to do that by writing my answer out in a complete sentence and then finishing up by reading the problem over again and immediately reading my answer and making sure that it sounds like something that somebody might use as their answer. All right, so with these ideas in mind, let's dive in and take a look at a particular problem. In this situation, 4 friends bought a lottery ticket and won $65,000. If each person is to receive the same amount of money, how much does each person receive? Step 1 of the problem-solving strategy is to make sure you understand the problem. As I said, I like to go back and take notes. In this particular situation, we have 4 people, 4 friends. We have a total amount of $65,000. And it is important that each person receives the same amount of money. And our question is how much each person receives, right? The thing we are looking for is how much is left. Sometimes I like to quickly label the question in my notes as WTK. Want to know. So a reminder to myself, these are the things that I do know, and these are the things I'm looking for. In this particular problem, it's not that bad. There's really only one thing we're looking for. We're looking for how much each of the 4 friends receive, but since they all receive the same amount, that's really just one thing. In future problems, you'll be looking at situations where you want 2 or 3 or more different pieces of information in your final result. Now that we understand the situation, we can move on to step 2, where we try to create some sort of a plan. Sometimes the plan jumps right out at you. If the question asks for the total amount, well, the total means the result when you add stuff together, so you're going to add stuff together. Sometimes it takes a little bit of thinking. Specifically, I'm going to go back and I'm going to look at this statement, which doesn't really look mathematical, right? The first 2 statements are pretty straightforward. 4 friends, number 4, $65,000 total. We have $65,000, right? I know I said there's a total there, but I don't have stuff to add together. The total is the result of adding stuff together, so that might help us. But the way that I look at this problem, each person receives the same amount. Another way of saying that, thinking about the English language, is that we want to divide it evenly. And that is where I start to look at something and say, well, that looks like a plan. I should circle that in blue. I'm using blue for the stuff I know. We have a plan. We need to take $65,000 and divide it evenly between the four friends. So our plan is to take $65,000 and divide by 4, which we'll set up using long division. 4 goes into 6 once. 1 times 4 is 4. Subtract that off, you get 2. Drop down the next guy, which is 5. 4 goes into 25 6 times. 6 times 4 is 24. Subtract that off, you get 1. Drop down the next guy, which is a 0. 4 goes into 10 twice. 2 times 4 is 8. Subtract that off and you get 2. Drop down the next guy, which is another 0. 4 goes into 20 5 times. 5 times 4 is 20. Subtract that off and you get 0. But we have another digit left to go. All right, pay close attention to how digits are dropping. We have to drop one more 0. 4 goes into 0 0 times. 0 times 4 is 0. Subtract that off and we have a remainder of 0, which is nice. So 65,000 divided by 4 is 16,250. Right? That's what it looks like to execute our plan. Step 4 is to interpret the plan. As I said, I like to take the time to write out the result as a complete sentence and make sure it makes sense. We're asked how much each of the 4 friends receives. Each of the 4 friends receives $16,250. Let's take a look at one more problem. A gardener is trying to decide how much fertilizer to buy for his yard. He knows that his lot is in the shape of a rectangle that measures 90 feet by 120 feet. He also knows that the floor of his house is in the shape of a rectangle that measures 45 feet by 65 feet. How much area of the lot is not covered by the house? This is the type of problem that I really love to solve using the strategy of drawing a picture to take my notes. I know that I have a lot which measures 90 feet by 120 feet. And I know inside that lot, there is a house. And the house is going to measure 45 feet by 65 feet. So there's my house. And I know that the problem is asking about this area. So in organizing my thoughts, in trying to figure out what's going on, instead of putting all of that into bullet points, I drew a picture. A picture is worth 1,000 words, as they say. But with that information, I can start thinking about how to plan this. And for me, looking at this visually makes a lot more sense than anything else I might want to try. Finding the area of this awkward looking shape directly could be a bit of a challenge. So instead, we have to think a little bit outside the box on this one. Notice that the area in white is what you would get if you took the entire blue area and you got rid of all of the red area in the middle. And that is exactly what we can use to solve this problem. If we can calculate the blue area and we can calculate the red area and we can subtract those things, then the result will be the area of the shape we are looking for. So let's go ahead and do just that. The area of a rectangle is calculated by multiplying its length times its width. So we want to take 120 feet and multiply by 90 feet. These numbers are a little bit large, but the multiplication is not that bad. I know that 12 times 9 is 108. So 120 times 9 is 1,080, and 120 times 90 is 10,800. Right? The 108 and then the 2 extra zeros tacked on at the end, 10,800. And if you multiply feet times feet, you get a result in square feet. I can do the same thing for the red area. The length and width of that rectangle is 65 feet by 45 feet. Now these numbers I can't solve as easily as the last one, but I can go off to the side. And I can jot down the multiplication 65 times 45. Well, 5 times 5 is 25. Write down the 5, carry the 2. 5 times 6 is 30, plus 2 is 32. Then move over one space. 4 times 5 is 20. Write the 0, carry the 2. 4 times 6 is 24, plus 2 is 26. Add that together, I get 2,925. And then finally, I said that the white area would be the blue area minus the red area. So I take the blue area, 10,800 square feet, and I subtract the red area, 2,925 square feet. Once again, I don't know those numbers offhand, so I'll go off to the side and perform the calculation. And doing this calculation, I'm going to have to do some borrowing. I have to do a double borrow here. Borrow from the 0, but there's nothing there, so borrow from the next guy. This 8 turns into a 7. This 1 turns into a 10, so I can borrow from that 1 to get 9. And then this 0 at the end turns into a 10. So I have 10 minus 5, which is 5. I have 9 minus 2, which is 7. I have 7 minus 9, which doesn't work. So I need to borrow here, make that a 10, borrow 1 from it to make that 9, and that becomes 17. 17 minus 9 is 8. 9 minus 2 is 7. So the white area of this figure is 7,875 square feet. Going back all the way up to the original problem, the problem is asking how much of the lot is not covered by the house. We called that in our picture the white area. We've calculated its value, but calling it the white area is nonsense to the gardener, because that's something we invented in the process of solving the problem. So we go back to the language of the problem used. There are 7,875 square feet of the lot not covered by the house. Once again, writing out a solution using complete sentences makes you sound a little bit more intelligent. And what's the point of coming to college if you don't become more intelligent? And what's the point in becoming more intelligent if you don't sound like it? So with that, we've solved this problem. Not much more to say. This is kind of the challenging end of what we're going to be talking about right now. In future weeks, we'll be looking at problem solving involving more and more complicated situations, more and more complicated operations. We'll be looking at solving problems that involve 3 and 4 and 5 operations. This one was 3 operations all told. But for now, take a look at the practice problems I have for you in D2L on how to solve problems. And I'll wrap this video up here, and I'll see you in the next one.